go online to this? Okay. I can hear myself coming out of the computer. Okay, we'll leave it that way for the moment because I do have a video that has a soundtrack. Tell you what, I will. It's the second. Get out of presentation mode here. When I get to the video, I'll turn the sound back on. Okay. So I retired from Raytheon almost a year ago and started 2 weeks later at Northrop Grumman Space Parks. I really didn't have much of a retirement. It was a solid 2-week retirement. And actually, I was teaching a class at Cal Poly at the same time, so it really wasn't much of a retirement. So the chart says I have more than 40 years of experience, and that's true. But I realized earlier this year that my first paying job as a space guy was in 1974 as a student at the University of Chicago. I worked in John Simpson's cosmic ray group, looking at data from IMP satellites, some of the early Pioneer satellites. And so really it's a 50-year adventure plus. Although, as I said at this panel that I was on in Vegas a few years ago, Marty, I see you're on your phone. You should be listening to my talk, but that's okay. I said that I'd been a space guy since I was in the first grade. And part of the reason I said that is we actually had a first grader ask questions, and he was clearly a space guy already. So I've written papers, helped write some books, including the new SMAD with Jim Wirtz. As I mentioned already, I went to the University of Chicago. I have a PhD in astrophysics, and we'll come back to that later in the talk. I'm a fellow of multiple societies, and I'm very deeply honored to be a newly elected member of the National Academy. I've been pretty active in the AIAA. I've been the LA section chair 3 times, I think, and Region 6 director. I'm currently the education director. And later on in the presentation, or in this meeting, I should say, I will be recognizing students from this section that were awarded prizes at the recent student conference in Santa Clara. Well, this summarizes my career, and I'm not going to spend much time on this in the interest of time, but I do want to emphasize again my long history in coastal water imaging. As I like to tell people, I've been working on hyperspectral imaging before it was even called hyperspectral imaging. We used to call it imaging spectrometry, addressing DoD problems. What band of multispectral bands are needed to solve a particular problem? Well, we said there isn't one set. You need an imaging spectrometer, and that was more than 40 years ago. Started my career, though, as an observational astrophysicist, and one of the benefits of being at Northrop Grumman is I get to dabble in that again as part of this team working on the Habitable Worlds Observatory, the next great observatory, which may or may not happen before I pass away. We'll see, but we certainly hope so. Okay, well, I think we would all agree that observing the Earth from space has really changed the way we see our home planet, my favorite planet, certainly. And as we go from, our, current era dominated by multispectral instruments, and I'll define what those are later in the talk, toward hyperspectral, we'll gain an even deeper understanding. And so what you see on this chart are frames from different things that I've worked on over the years, all at Raytheon, actually, where I retired from last year. MODIS in the upper left, VIIRS, one of the blue marble images in the top center, more VIIRS imagery, something called JAMI, geostationary weather imager for Japan. And finally, in the lower left, VIIRS day-night band, a low light level imager, continuing the proud legacy of DMSP, operational line scanner for amazing low light level imagery. Well, I think it's fair to say that this is probably the single most important environmental photograph ever taken. And those of you who are roughly in my age range, I'm sure will remember this Christmas Eve of 1968, where we watched black and white imagery coming back from the moon as the astronauts orbited the moon for the first time, and snapped this photograph with a Hasselblad camera, not a lousy black and white TV camera that we saw it on live video. But it really changed the way we perceive the Earth, seeing it from a distance in this way. See if I can get the sound to come back. Hope you'll be able to hear it. Yes.
But as soon as we made it beyond the limits of our atmosphere, one of the first things we did was turn our cameras around and look at it. The first satellite was launched was 11 years before Neil Armstrong became the first person to walk on the moon. Explorer 1, built under Jet Propulsion Laboratory, initiated a long line-of-duty satellite thanks to our understanding of Earth's height. In 1997, NASA launched the satellite and began the 20-year record of that, as far as we know, Earth's special life. While most satellite missions are testing now,
There it is. Okay. Never had to do stereo.
Life itself. The result? The most complete view of global biology to date.
The greatness of this data set is kind of hard to explain. It allowed me to understand ocean in such an organic way.
That's the voice of oceanographer Dr. Ivona Sitinic. Ivona and the rest of the NASA Goddard Ocean Ecology Lab help oversee the 20-year dataset. If you take a closer look at this animation, you'll see what looks like a repetitious ebb and flow on the land and surface of the ocean. We're actually watching the planet breathe.
About half of the total photosynthesis on the planet occurs on land and half in the oceans.
That's Dr. Compton Tucker, who pioneered satellite monitoring of vegetation on land. The spring and summer months kick off the growing season for plants on land, illustrated in dark green, and tiny microscopic plant-like organisms in the ocean called phytoplankton, seen in the light blue. They take carbon dioxide out of the atmosphere and use it for energy, causing the total amount of carbon in the air to drastically drop. The opposite is true during colder months. During winter in the northern hemisphere, which is home to most of Earth's land plants, carbon in the atmosphere increases as plants go dormant. And then there are extreme zones in the ocean. Purple patches are nearly devoid of any phytoplankton. They're basically deserts at sea, while the red zones tell us that there's either a high concentration of phytoplankton hugging the coastline, or our satellite sensors are picking up on another input changing the color of the water.
We have a marvelous biological diversity of plants and animals, both on the land and also in the oceans.
But hold on. If we have an amazing biological diversity of plants and animals, why do scientists spend all of their time observing plants?
You know how they say you are what...
As soon as we made it beyond the limits of our atmosphere, one of the first things we did was turn our cameras around and look at this.
Sorry about that.
The first U.S. satellite was launched in 1958. That's
I'm hearing
11 years.
I'm tracked twice up there. So. Yeah.
Moves further north and recedes. It's then followed by very, very green colors because plants are really photosynthesizing in those dark green periods.
Scientists think that there are likely trillions of planets, yet Earth is still the only planet we know of with life. And with that in mind, our habitable homeworld seems ever more fragile and beautiful when considering the vastness of unlivable space.
I have several friends and acquaintances who are astronauts. They all say the same thing. When they're in orbit, on the space shuttle or in the International Space Station and look down at the Earth, they see one climate, one planet. We're all in this together, and we need to work together to make sure that life as we know it continues on this wonderful planet.
All All right. Yeah, we're definitely all in this together. So, all right. Well, I'm going to go ahead and just manually turn the sound down. Computers. Yeah. Yeah. Got it. All right. Let's continue.
3.
All right. Okay. So we can follow the development of ecosystems from space today with multispectral imagers. The importance of this for the nation and for the world is to be able to optimize the worldwide economy, to understand the effect of natural disasters and unnatural disasters like oil spills on marine economies. These charts are actually taken from Jeremy Wardell, who's the chief scientist for something called PACE, that we will talk about later in this presentation. So 40% of the world's population lives within 100 kilometers or so of a coastline. 12% of the world's livelihoods are really supported by this ecosystem of fisheries and aquaculture. The ocean economy, as you can see on the chart, contributed more than $282 billion to US GDP and provided more than 2.8 million jobs. Meanwhile, harmful algal blooms remain a serious problem, a serious threat to the life and safety of Americans, certainly, and others around the world. Well, how do we address this problem? How do we develop the more detailed, thorough understanding that we need to really be able to understand the impact of change on these ecosystems and ideally in the future predict when these changes might occur? Well, I would argue that it's space-based imaging that provides those tools. Certainly you can do it in situ, you can measure the properties of water, coastal waters in the actual body of water, but if you look at the cost of doing that at the level of detail that you can do it from space, it turns out doing it from space is a great bargain. And it's really the understanding of these changes that will impact our ability to respond to climate change and other natural disasters and that may be associated with that. So really what we're looking for from this data is the understanding that we need to enable this reliable forecasting. And I'm going to argue that a hyperspectral, high spatial, spectral, and temporal resolution imager in GEO operating in the UV near infrared is the way to do that. Let me just explain briefly these photos that you see. At the upper right is the Mississippi Delta region. This is a frame from Terra Modis showing the impact of a recent hurricane, of a storm surge that basically killed all of the vegetation in these coastal waters from the storm surge. Down below, if you look carefully, you can see suffocated fish from a red tide in Florida. Well, let me give you a brief lesson in remote sensing from space. So when we look at the Earth from space, we can divide the type of light we see into two broad categories. One we call solar reflective, which is at visible near infrared wavelengths, actually all the way through the shortwave infrared. During the day, that is from reflected sunlight, but at night we can see city lights, we can see aurora, we can see many things at night with the right imager. All the time, we see thermal emission from heat, from the surface, from clouds, from the atmosphere. We call that thermal emission, and that occurs longward of roughly 3 microns, going up quite far into the microwave. We look at the Earth across the broadest possible spectrum because the Earth looks very different at different wavelengths. So here you see our beautiful state of California as seen from the GOES weather imager. And in the lower left, you see visible wavelength imagery showing clouds, showing snow on the Sierra, coastal clouds, of course. If we go to the near infrared, it looks pretty much the same. But if you look closely, you'll see there are differences. Vegetation, for example, shows up better in the near infrared than it does in the visible. And I'll explain why shortly. As we go out to longer wavelengths, when we get to the mid-infrared, now we're seeing thermal emission almost exclusively, and we're seeing that from hotter objects because they emit at shorter wavelengths than the thermal infrared, which is basically around 10 microns. And here you see colder objects, sort of room temperature-like objects, and you can see the coastal cloudiness off the coast of California. We tend to look through windows in the atmosphere. And so this plot at the top shows attenuation in dB. Clearly, this was done by an electrical engineer versus frequency and wavelength. For coastal water imaging, we look in windows of the atmosphere that are out here in the visible through shortwave infrared, really, sometimes as far as the UV. But you can see there are great windows in the atmosphere at much longer wavelengths, much lower frequencies in the microwaves. And in the infrared, we look through these windows that are defined by basically the gaps in absorption between molecular absorption, so CO2, water vapor, ozone, et cetera. Well, so if we go to the next level of detail, we can follow the photon basically from the sun down to the earth and then back to the sensor. And we're not just seeing light reflected from the Earth itself. We're seeing light scattered by the atmosphere. Some of it gets absorbed, of course. In the thermal wavelengths, we see emission from the atmosphere and everything else. If we really focus on coastal water, oops, let me go back. You can see how complex this problem is, and I'm not going to lead you through every one of these paths. But the thing I want to leave you with is that when we look at coastal water, look at the open ocean from space, almost all the light we see actually comes from the atmosphere. And that creates a big challenge for us in processing the data. It forces us to go to very high sensitivity, very high signal to noise ratios so that we can effectively subtract out the light scattered by the atmosphere from the signal that we measure. That is explained on this chart, which I'm not going to go over. I just want you to be overwhelmed by the complexity of the process that is that is required to do that. Yes, of course. Yes, absolutely. Okay. So I promised I would tell you what about the red edge, first of all. So when we look at water from space and actually land vegetation as well, we see a feature that we call the red edge, and that is shown here, if I can stabilize the cursor. This high peak is actually a feature associated with chlorophyll. So chlorophyll, of course, is responsible for photosynthesis. It absorbs sunlight and creates sugar and oxygen, both of which are very beneficial to all life on this planet. But in a sense, it can't do that across the full spectrum. And so it actually reflects the light in the red. Unfortunately, the sun turns out to be brighter at the wavelength where chlorophyll absorbs the light, and I don't think that's an accident. And so the fact that it shows up, that chlorophyll vegetation in general shows up as being brighter in the red is a good way to find vegetation on the Earth. But you see, when you look at different kinds of water, what the range is. So we're looking at, this is percent reflectance on the y-axis, so up to almost 12% at the maximum part of the red edge, down to almost 0. And so this range, is from very biologically active water with a lot of chlorophyll, a lot of algae, et cetera, down to almost pure water, which is extremely dark at visible wavelengths. And there's a lot of other stuff in between. There are dyes that are formed in rivers in particular from decomposed sediment that show up. It's actually a Danish word, gelbstoff, yellow stuff, basically, from the famous Danish oceanographer Yerlof that we see from space as well. Well, if you look at this worldwide map of chlorophyll A, which is an indicator for biological activity, you can see that most of the biological activity, at least in our part of the world, is along the coastlines. Again, emphasizing the importance of coastal water. The open oceans are basically biological deserts. There are no nutrients. Along our coastline, in particular here in California, we have a lot of upwelling that brings nutrients up from the bottom and really fertilizes an amazingly productive ecosystem. You see the Georges Bank off the coast of Newfoundland. That's also a very active fishery. Likewise, the Baltic and the North Sea, mostly the North Sea there, also very active. We can also see a lot of other things going on. If you look closely, you'll recognize California again. So here we are right here in El Segundo. And you can see on this particular day, there was a Catalina eddy going. We had one today as well, and hitting maybe more of the central coast up by Solvang, Lompoc. You can see all this interesting structure, but when you look at it from low Earth orbiting instruments like this, and this is from VIIRS, you get, maybe 2 snapshots a day. You don't really get a good sense of the dynamics of what's going on in the coastal water. Likewise, this shot, which is pretty amazing, taken of what we used to call the Sea of O back in the Cold War days, the Sea of Okhotsk near Vladivostok, where the Soviet Union used to have submarines. I don't know what's going on there these days, but very active, turbulent inlet off of the Pacific Ocean. Finally, Lake Erie, which is a very important source of drinking water for both the US and Canada. Of course, you see Cleveland, Detroit, Toronto is actually over on Lake Ontario, but occasionally Lake Erie has these red tides, basically, that make the water undrinkable for literally millions of people. Okay, continuing with my lesson of space-based remote sensing. There's several different orbits that we use frequently. One is geosynchronous, sometimes called geostationary when the satellite's actually on or very close to the equator. And of course, the intent there is to synchronize the orbital period of the satellite with the rotation of the Earth. So it's a good place for weather satellites. It's also a good place for remote sensors that want to look at the same part of the world all the time. Sun-synchronous orbits are a very clever orbit. That's not obvious, by the way, that you can even have an orbit like this, but they're basically enabled by the non-spherical shape of the Earth. Earth is an oblate spheroid, and you can use the torque, the gravitational torque associated with that bulge around the equator to, with the right orbit, to keep the satellite in sync with the sun. So in this case, the satellite comes over at essentially the same time of day everywhere on Earth. Not quite that simple, but that's the basic intent. And so this is a very good orbit for climate measurement systems, like the Aqua satellite for NASA, JPSS. Landsat is also in that same kind of orbit, where you want to have the same illumination conditions, same time of day, every day throughout the year. Another type of orbit is a highly elliptical orbit, or Molniya orbit. This orbit was invented by the Soviet Union way back when. They needed it to reach military bases and populated centers in the very high Arctic, very high latitudes, which you can't reach from GEO. You really can't see the poles from a geostationary orbit. But it's also very helpful remote sensing. These orbits are designed so that they dwell over say, the polar region, the North Polar region. And so you can basically operate like GEO, except at very high latitudes. There are polar weather imagers that are planned that are going to do that. And of course, missile warning sensors like NGP operate in orbits like that, or will operate in orbits like that. Then there are other low Earth orbits like the TRIM orbit, Tropical Rainfall Measurement Mission, that was in a very low inclination so that it spent all of its time over the tropics. Well, this is what you can see from GEO. You can see this is a weather system over the Midwest. I think this is actually maybe Kansas or Oklahoma. And you can watch these storms developing. You can see that the more often you revisit this scene, the more detail you can see. And that's the basic idea. Spectral resolution is something we care a lot about, especially in this talk on hyperspectral. So basic categories of resolution include panchromatic, very broad spectral bands. So you get a lot of light through that band. And so you can use that to get good sensitivity, amazing sensitivity actually, or higher spatial resolution. Multispectral, as I mentioned before, is where most of the work has been done. These are sort of moderately wide spectral bands, typically 10 to 30 of these bands at a given sensor. And what you can do there is you can recognize major features, you can distinguish rocks from trees, crops from water, et cetera, but not much more. Really, where things become interesting is when you get to hyperspectral imaging. In this case, you're literally typically talking about hundreds of bands, narrower wavelengths ranges for each band, but contiguous is really the point. So you have spectral samples that are right next to each other, so you can get a complete picture of what's going on. And once you have that, you can recognize the types of minerals, the types of trees, what's actually in the water, what types of microorganisms, literally. You can also measure the depth of bodies of water, not too deep, but somewhat, but of depths of interest. And I'll show you an example of actually doing that with multispectral in a few minutes. Finally, ultraspectral imaging, which is even higher spectral resolution. And this is used primarily for imaging gas absorption features in the atmosphere, for basically mapping out the physical structure of the atmosphere and temperature, water vapor, detecting and measuring trace gases in the atmosphere for different purposes. All right, well, let me just go through these very quickly. So this is a panchromatic image taken with VIIRS built by Raytheon. This is a panchromatic band showing a hurricane arriving in Louisiana, about to hit New Orleans. You can see all the city lights along the eastern part of the US. Recently, VIIRS actually detected bioluminescence. So that's light from microorganisms glowing at night. I've seen it. In fact, the very first time I saw it was down in Del Mar when I was at UCSD and we were coming home from dinner. And there's the blue bioluminescence along the beach just south of Del Mar. And you can see it here all the time too. You can see it in Hermosa, among other places. Multispectral imaging basically does enable these large-scale environmental studies. This is CWIFs showing the Atlantic, the biological desert in the Sargasso Sea, the biological activity at the Amazon Delta, et cetera. You really can begin to understand the couplings between these different elements in the ecosystems. So recently a paper, this was just published a couple of weeks ago, actually, by a French group where they use something called Sentinel-2, which is basically the European version of Landsat. And they were measuring the depth of bodies of water just off the west coast of France. And you can see it actually works pretty well. This, again, is multispectral. With hyperspectral, it works even better. And so you can see down to a depth of about 25 meters. So getting close to 100 feet, you can actually get pretty good correlation between the satellite measurements and a hydrographic database. Well, the future of space-based imaging is hyperspectral. And the reason for that is we need the more detailed understanding that is enabled by hyperspectral imaging. If you don't believe me, I recommend you look at what is going on now with the GeoXO system that NOAA and NASA are deploying over the next 5 to 10 years. There are 5 different instruments in that system. 3 of them are hyperspectral. The 3 hyperspectral ones are OCX, which is an ocean color imager, an atmospheric composition imager, and GXS, which is an ultraspectral sounder. Well, the problem with hyperspectral data, though, is it creates so much data. And so if you look at the history of space-based imaging, going back to, say, the mid-60s or so, the data rates that, my battery's running low, okay, it's good to know. Uh, 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 we had effective data rates in the mid 60s of about 150 bits per second. Of course, we didn't have, there we go, that's better. We didn't have digital communication back then, really, not for space-based systems. So that was an estimate, but going all the way up to the near future where we're going to have data rates in the 75 gigabit per second range. So that creates huge challenges. What we're doing today typically is throwing away like 98% of the data because we simply don't have the bandwidth to get it all down to the ground. There are many solutions to this problem. One, of course, is onboard processing, where we would process the raw data to products that are then sent to the ground. Okay, well, this is the concept of hyperspectral. You might wonder, well, why is there so much data? Well, the data we collect with hyperspectral imagers is called data cubes. And the reason for that is shown here, where you can sort of imagine a two-dimensional photograph, but because you have literally hundreds of spectral channels with hyperspectral, you have hundreds of times more data with a hyperspectral system than you would with a typical multispectral system. Hyperspectral data also contains a lot of detailed physical information. So here you see reflectance data for alunite, which is a mineral. This is thematic mapper. That's an early version of Landsat. You can see the spectrum is very coarse. If you go to MODIS, which is a more modern multispectral, you can see a bit more detail. But when you go to the hyperspectral resolution, now you can see tremendous detail that allows you to recognize alunite and separate it from other minerals. And that's been done on Mars. It's been done on the Earth. It really works. All right, well, I'm going to go through the history of ocean color imaging, but then really focus on PACE, which was just launched in February, and Glimmer, which is coming a few years from now. All right, the Coastal Zone Color Scanner was the first space-based coastal water imager. It was launched in '78. I actually used data from CZCS when I was doing some work for the Department of Defense in the early 1980s. It was the only source of data we had that covered the globe. It wasn't very good, I'll tell you that, but as I said, it was all we had, and it was very valuable for its time. It was built by Ball Aerospace, which is now part of BAE. CWIS was the next one. It didn't come along until the late 1990s. It was built by what is now Raytheon. It was actually built by Santa Barbara Research Center up in Goleta. That's actually where I started my career with Raytheon. It was Hughes as I joined, became Raytheon shortly thereafter. But this was built up there. It was the first commercial remote sensing system. It was built for a company known as Orbital Sciences, which is now part of Northrop Grumman. Most people say that CWIS is the finest ocean color imager ever built, and the reason for that, it was optimized for ocean color measurements. As a rotating telescope, you can actually tip the entire instrument to avoid glint. And it had a depolarizer, actually a polarization scrambler, to mitigate the effects of straight light and scattered light in the atmosphere. These are the bands. I'm not going to dwell on this, but these bands go from really the edge of the ultraviolet all the way to the end of the near infrared. These are the classic bands, and they'll show up in all of these instruments. So CWIS was used for other things as well. It provided valuable data for disaster monitoring, such as in the case of the eruption of Popocatépetl back in 2000. You can see the volcano sort of in the center. Uh-oh. I think I just have to play. Sorry about that. Is there an outlet? I looked for one before. I didn't see one. You built out? No, I think it's power. Power. Yeah. Sorry. Yeah. No. Sorry. Yeah. Yeah. Sorry, folks. Yeah.
Yeah, sorry for the temporary situation. First, I want to apologize because actually this is an amazing talk. Indeed, it probably take 1 hour, 2 hour. So actually, we are being inviting Dr. Puchel for giving a longer talk. But it happened that this award dinner comes first. So I checked with Jeff and he agreed to. You can see some.
And by the way, I was
flavor.
kidding about the hour and a half. Okay, so
Thank you. So
I was definitely kidding, but
So this is actually the preview,
that's right. Yeah, this is the preview.
preview and give you CC a flavor of it. So hopefully later on Jeff can have more time so we can have a
Yeah.
full,
Why don't I apologize for the disruption here? I'm gonna go ahead, log back into the Zoom meeting.
take easy, take easy.
Yeah.
Yeah, try to fill in for some of the story here. So as you know, Jeff has been, the leader in this remote sensing. And another thing I want to apologize because earlier I was mentioning the former council member. I actually forgot to mention the biggest one, Dr. James Worth is our former section chair. He was sitting right here, is like a son, and I just see the career, but he's our main person. That's why we have the James Worth Scholarship, which later Jeff will announce it for this year's winner. And actually people here from Millennium and to a couple of members and the Cal State Long Beach student too. And tonight we actually supposed to have the people from Spin Launch. They just text me they have some busy meeting this afternoon. Hopefully they can still make it. So the story was we have a student branch mini conference, in February, and we actually the Spin Launch people was talking about responsive space, and they said, "Wow, this is a great idea." They were trying to get into this responsive space. I just told them, Dr. James Worth, we have the responsive conference with a section. And you know what? Then he was kind of suspicious what I was talking about. Then, we have a member, Dr. Thomas Heisheimer, Aerospace Corporation, and he just walked in and to share the conversation. And Spin Launch people just saying the same thing again. And the Dr. Tom Heisheimer told them exactly the same thing I was saying. We should talk to Dr. James Worth, Responsive Space Conference. And so they said, wow, I mean, this is wonderful. They definitely want to come here and meet Dr. Worth personally. So let's tell you, how amazing Dr. James Worth has been contributing to the community, and everybody was doing. Even now, they actually don't know his name, but they know they need to follow the responsive space.
So Ken, I'm sorry to interrupt you. You have to upgrade me to a panelist.
Oh yeah, sorry. I don't see you here though.
I was there, but I disconnected, hoping it would prompt me again automatically.
Okay, here.
It did before. But yes, it's going to allow me to talk. All right. All right. Thank you, Ken.
Sorry for this. So share screen.
Yeah. Okay. All right. I'm going to share my screen. And I'm going to pick up the pace here to get us back on top. Okay. All right, so Popocatépetl. Yeah. All right, let's continue. Let's go on and talk about MODIS. MODIS followed CWIFS. MODIS was launched first in 1999 on Terra, then later on Aqua in 2002. Both MODIS systems are operating today. This is sort of the quintessential multispectral instrument with 36 spectral bands. One of the really innovative features of MODIS was the calibration systems that were developed and first demonstrated on MODIS, especially at solar reflective wavelengths with the diffuser you see in the upper right corner. These are the spectral bands. The real point of this chart is to show you how many of them relate to ocean color. It's a very important measurement. And in this omnibus, sort of Swiss Army knife kind of imager, more of the bands are related to the ocean actually than anything else, and many of them to ocean color. Well, VIIRS came next. Oops. Let's go back. Apologize for that. Maybe that was a hint. Not sure why it advanced like that, but anyway, so here's VIIRS. The first VIIRS was launched in 2011, named after Vern Sumey, professor at the University of Wisconsin, who invented the weather satellite. VIIRS has 22 bands, somewhat better spatial resolution than MODIS and most bands. VIIRS was a challenging thing to develop because it combined requirements from 4 different instruments, 2 of which you've already heard about, MODIS and CWIFS, OLS from DMSP, and AVHRR, which was a NOAA multispectral imaging radiometer. These are the VIIRS bands. Again, you can see that well over half of them are related to ocean color. GOSI is the first geostationary ocean color imager. It's built by Airbus, a French company, for South Korea. And the first one was launched back in 2011. GOSI 2 was just launched roughly 4 years ago. And as a big step up, it provides full disk coverage in 12 spectral bands. And certainly a very pioneering system. Another pioneering system is called MERIS. This is a European system. Basically, let's see if I can find the cursor. MERIS consists of 5 different cameras, all of which are hyperspectral, but it never produced any hyperspectral data. What it did instead was produce virtual multispectral bands where the individual spectral measurements were combined together into these very broad simulated multispectral bands. And these are the MERIS bands. You can see a much larger number, 15, covering that spectrum more completely. It was very pioneering, but still surprising that they didn't use it as a hyperspectral imager. Nevertheless, it was a pathfinder for the system that's flying today, something called OLCI on the Sentinel satellite, Sentinel-3, I believe. Okay, well, PACE is the next one. PACE is hyperspectral. I was on the PACE science definition team. I was the only guy from industry on the team. One of the features of my career has been all the engineers think I'm a scientist and all the scientists think I'm an engineer. And it works out beautifully, actually. I really like being in that spot. So PACE is basically a hyperspectral CWIFS. It has a rotating telescope. It's much larger. It's a very clever instrument, actually. It's a 1-pixel design where it improves its sensitivity by essentially co-adding samples along the scan direction, the mirror scan direction. Roughly the same resolution as CWIFS, 1.2 kilometers. It covers the globe every 2 days. We could go on and on, actually, about PACE OCI. But I'm happy to report that PACE data is now available online. This was the very first light collected from PACE. It was collected on Dana's birthday this year, February 28th, or released publicly on April 11th. Dana was a zoologist, by the way, so a limnologist, maybe to be more precise. So this is right up her line of interest. But the thing that's amazing is when you look at this, and this is South Africa, you can see from the PACE data, you can recognize different populations of microorganisms. You can see, the chlorophyll A itself. But what it's really showing here, this processed hyperspectral data, is showing you where these different populations are. Data like this is very valuable for many different communities, including the Department of Defense, that really does want to know what's in the water in certain parts of the world. Well, let's move on to talk about Glimmer. So Glimmer is still in work over at Raytheon across the street. The PI is Dr. Joe Salisbury at the University of New Hampshire. Antonio Menino at Goddard is the deputy PI. The team at Raytheon includes Ed Chung, the program manager, Jeff Yee, chief engineer, and John Bloomer, the lead system engineer. As you can see, and I hope you've retained some of the details in the brief introduction to remote sensing, Glimmer goes from the UV, from 340 nanometers, all the way out really to the edge of the shortwave infrared. So of all the systems you've seen so far that are dedicated to coastal water, this one has the broadest spectral range, the highest spectral resolution, and the fastest coverage rate. So it's really going to truly revolutionize our understanding of coastal waters in the Western Hemisphere, because it's going to be over the Western Hemisphere. Well, I had something to do with getting Glimmer started. In fact, if you want to see the Glimmer mobile in person, it's here in the parking lot. I was very optimistic. You know, I've written a lot of proposals, I've been involved with a lot of proposals in my career, and I know when a good proposal is being sent in. I just know. And I knew this was going to win, although you never really know for sure. But I went ahead and bought the personalized plate anyway, and we did win Glimmer at Raytheon. So, very happy to have been a major contributor to that effort. So I could spend 30 minutes really talking about this chart, but I won't do that. But suffice it to say that it illustrates the complexity of coastal water with storm damage, seeps and spills, biological activity, et cetera. All these things need to be viewed at high spatial, temporal, and spectral resolution to really get the understanding we need, and Glimmer will do that. So Glimmer will be able to basically look at any part of the full disk that's within reach of its longitude. So the expectation is that it will be placed at a longitude that would put it essentially directly over the Gulf of Mexico. And really the highest priority science need is to look at the Gulf of Mexico, but it will during its typical day start, you know, in the east, start in the Caribbean or the Amazon Delta, go on to the East Coast and to the Gulf of Mexico, the West Coast, Hawaii, South Pacific. Glimmer will be very busy during its operating lifetime. Well, as engineers, we needed to have a definition of the Gulf of Mexico so that we could prove to our customer that we could in fact cover it. And we got lucky. We really got lucky. It turned out that the focal plane assembly that was available behind the optical design we had just happened to provide a swath that was wide enough to cover the Gulf of Mexico. So this is the official definition, and we can cover that in about 70 minutes. This is a plot of signal to noise ratio. You can't read the numbers. I apologize for that. But this peak signal to noise ratio is about 1400. So you recall some of the early systems were about a factor of 10 less sensitive than that. So Glimmer will be the most sensitive, and really the scientists are very excited about what they're going to get from Glimmer. Well, one of the challenges with Glimmer, in fact, I think the single biggest technical challenge in Glimmer is line of sight knowledge. And for those of you who are familiar with GEO and you think about how many microradians we're talking about here with a 300-meter ground sample distance, it's a real challenge to maintain line of sight knowledge, and jitter will be a factor. All sorts of things will be going on board that space vehicle that will have to be mitigated. And the way that's going to be done with Glimmer is to look at these landmarks. So these are landmarks that the GOES program established. They're based on Landsat ground control points, but Glimmer will be able to look at these landmarks at the same time it's looking at the Gulf of Mexico and other parts of the world. And so we'll be tracking line of sight simultaneously with the data collection. Well, as I mentioned, at Northrop Grumman, I've had some involvement with future great observatory for exoplanet studies. And so it's obvious for me, at least, to ask the question, can we detect oceans on exoplanets? And people have looked at this, and there have been a variety of studies. One that I thought was interesting was published about 5 years ago, where they said, yes, we think that we might be able to see glint. Now, remember, I said we don't like glint when we look at the Earth because glint obscures the signal coming from the water itself. But if you're just trying to see whether there are oceans on other planets, this glint spot that's blinking at you as the planet rotates could be very useful. So we'll see how that works out in the future, but it sounds promising. Well, so in closing, let me just say these emerging hyperspectral systems really will revolutionize our ability to understand coastal water ecosystems. We'll be able to pick out the different constituents in these waters. We'll be able to track ecosystem response to environmental change. As I told the Glimmer team several times, Glimmer data will be on the Today Show. When a hurricane hits the Gulf Coast or whatever, they'll be using Glimmer to track the response of those ecosystems to that natural disaster. Ultimately, we'll be able to forecast the impact of these changes, which will improve quality of life, really, for all of us. As I mentioned, PACE was launched on February 8th of this year. Glimmer's going up hopefully in 2027, and it will be a pathfinder for a whole new generation of operational system called OCX. So what lies beyond? Well, to quote Lustig Jaeger, the discovery of an ocean on an exoplanet will transform exoplanet science by unveiling a truly habitable planet beyond Earth, bringing us one step closer to answering fundamental questions on the prevalence of life in the universe. That summarizes my whole life right there. Thank you very much. And I apologize for the disruption.
Yeah, thank you, Dr. Purcell. This is amazing. As I said, this is a preview. I'll give you a flavor. So we're working on the full lecture as it goes. Thank you.
Oh, you're welcome. My pleasure.
Thank you. Okay, so our next step is our Technical Excellence Awards. So with this, we have Dr. Purcell presenting the awards, and here. So in your program, you can see the organization, the company who got awarded this year. So I'm going to present it on the screen. So Dr. Purcell, so you can present the awards to the winner, the company.
Well, it's my pleasure to present this award, which, by the way, you know, is if I do say so myself, a fairly prestigious award. Certainly, it recognizes technical excellence in the Los Angeles area. And if you look at past winners, including JWST, SpaceX for the first landing of a first stage, you know, you're joining a really elite group of past winners. So congratulations, first of all. And it's really my pleasure to present the 2024 Technical Excellence Award from the Las Vegas section to Millennium Space Systems for Victus Nox small satellite. So thank you. So much. You're welcome. I think so. Yes. Okay. It's your own program.
I'll hold your chart.
Okay, great, thanks. All right, so yeah, while he's pulling up the charts here, yeah, just by way of introduction, my name's Andrew Chow, program manager for the Victus Nox program with Millennium Space Systems. I also kind of just wanted to acknowledge the team overall on the program, but specifically some of the folks here to join us. Yeah. And so, you know, this wouldn't have happened, you know, of course, without our customer, Space Safari. And so we have joining us here Lieutenant Colonel Mackenzie Birchenough and Lieutenant Colonel Jason Altenhofen. If you just want to raise your hand here and also, you know, we have some folks that were kind of, you know, rolling up their sleeves and getting their hands dirty on the program also. So got Randy Yunt here, mission director and one of our mission ops leads on the program. We've got Evan Arns, who's our assembly test and launch operations lead on the program. Greg Less, launch service integration. Kyle Yang he's our chief engineer for the company, and then Dana Carroll as our vice president of marketing. So yeah, another round of applause for these guys here and their really great work. Thank you. Do I have control here? Oh, okay. Right. Yeah. Yeah. So just next slide, please. All right. Yeah. So as I mentioned, the customer for the Victus Knox program was Space Safari, which is a program office out of Space Force SSC, so Space Systems Command. It was a tactically responsive space mission, or TAC-RS. And really what that means is that it was, a demonstration of our nation's ability to respond to on-orbit threats in tactically relevant timelines. And so really what we were trying to do was deliver a spacecraft on orbit and operational, really on a timeline that's never been done before. And, to perform a space domain awareness type mission. Next slide. And so, at a very top level, what does that look like? Really, you can break down the program into, a series of 6 distinct phases. So at first, there was the build phase, which included the space segment, so manufacturing of an operationally ready spacecraft in 8 months, the development of a ground segment, so building up the ground infrastructure to operate a system securely, and then also developing all of the logistics for the remaining phases. And I think kind of throughout the program, we kind of jokingly said for this particular mission, the rocket science was the easy part. We had to, develop pretty extensive logistics sequence in order to execute these pretty tight timelines. Really, again, something that's never really been done. And so, following the build phase, we entered what we called the hot standby phase, more or less simulating a real world scenario where, at a moment's notice, within a 6-month window, we could get a notice to activate. And what that meant is really these following 4 phases. So as soon as we received a notice to activate, we had to process our vehicle and have it launch ready. And so what that means is shipping it from headquarters here at Millennium Space Systems, which is just down the street here in El Segundo, up to Vandenberg Space Force Base, processing the vehicle and integrating it onto the launch provider's payload adapter frame. In this case, launch provider was Firefly Aerospace. Following that, we entered another waiting period, again, simulating real world events, which was a 30-day wait period, the alert phase. And then again, at another, moment's notice, we would receive a notice to launch, which initiated another very complex sequence to integrate the spacecraft onto the rocket and launch it into orbit in 24 hours. And then once we were on orbit, once we've separated, we had another record that we were trying to break, essentially getting the vehicle mission ready in just 48 hours. And just kind of want to emphasize, traditionally, starting from the activation phase on, this is typically weeks or months. And so what we accomplished here was just in a matter of days. And that's not to say getting a spacecraft manufactured and prepared for launch in just 8 months is also pretty unprecedented. I guess another piece, just kind of overall, is the mission. One of our aims, one of our goals was really not to manipulate or change any of the existing processes or systems in order to move fast. In fact, what we wanted to do was really stress test them to identify gaps, see what broke, so that we could then apply those lessons learned to future missions. All right, next slide, please. Cool. So, as I mentioned, we had to get a spacecraft ready in just 8 months. Not only the spacecraft, but also a ground segment and all the logistics for the future phases. So one of the primary things that we did. Oh, great. All right. That's dangerous. Yeah. Yeah. So, one of the primary things that we did, really because, I think at Millennium Space Systems, we kind of pride ourselves in being fast, but, 8 months is especially fast. And so what we did was we kind of leveraged an existing production line of space vehicles. And so we pulled one of the vehicles off of that production line. It was originally designed for geosynchronous orbit. So we modified it to operate in low Earth orbit. And we really took advantage of the vertical integration that we had in-house with the common core components that we've developed at Millennium that kind of work across the spectrum of different environments and orbits. So yeah, we modified that bus to perform this specific space domain awareness mission. And then, also we took advantage of a lot of the infrastructure that already existed within Millennium on the ground segment side to establish a space operations center within our headquarters. Cool. And so, with the spacecraft complete, it was parked in storage at headquarters, kind of in an environmentally friendly area. And from there, it was really just a waiting game. I think the complexity of this, I also wanted to highlight too, because, one of our primary challenges across the board on this program was maintaining the personnel and the infrastructure to support an anytime delivery of a system. And that's no easy task, right? So, for the activation phase, it was a 60-hour period. So 5 days, 24/7 operations in order to get the vehicle set up. So we had 20 individuals, 2 shifts, working 12-hour shifts. And so you can imagine if we got the call at 2 a.m. on a Sunday, on a holiday weekend, you had to have the personnel in place, you had to have the infrastructure in place, the subcontracts, the mission partners, everything ready to go at a moment's notice. And so at 8 a.m. on Friday, September 8th, we did receive that notice to activate. And kind of the way I like to describe it is for the better part of a year, we were kind of setting up domino pieces, and each one of those domino pieces was a different aspect of the logistics or the technical development. And really, with a single call from the customer, in this case at 8 a.m., it really kind of knocked down that first domino piece and really initiated an extremely complex sequence of events, that branch across all the mission partners in order for us to complete the activation phase in just 60 hours. And so, what we did was, shift 1 showed up at headquarters, shift 2 went immediately out to Vandenberg Space Force Base to immediately begin their crew rest. Shift 1, we packed up the vehicle in a truck and transport it on ground out to Vandenberg Space Force Base. Actually, for this mission, a new payload processing facility was built out there on base by the Firefly Aerospace team. And just another technical challenge that we had to do in unprecedented timelines in order to meet our mission needs. And then once we got there, after unloading the vehicle, after unloading all our ground support equipment, we kind of initiated the sequence of processing the vehicle. So there's an extreme amount of detail in each one of these steps, but at a very high level, we performed baseline functional testing. We did pressure demonstrations of our hydrazine fuel tank, testing batteries, charging batteries, actually performing the fueling operation on a highly toxic monopropellant, and then finally integrating that vehicle onto the payload adapter fairing. And then again, entering another storage period in the alert phase. Yeah, and so on September 13th, we got the notice to launch. And really just a huge credit to the Firefly Aerospace team. They took on a majority of the legwork in executing this time frame. Although, Millennium did have a hand in that work. So after we completed the activation phase, we had co-located a few folks from the assembly test and launch operations team, the ATLO team, in Vandenberg to support integration of our space vehicle onto the rocket, as well as perform some remove before flight type activities. We also had co-located our launch integration team, so myself and Greg Less here, to monitor the health of the vehicle throughout this 24-hour integration period and launch period, and to really respond to any anomalous telemetry that we were receiving throughout that phase. Also, of course, we had to notify our folks back home at HQ that we're going to catch the vehicle on orbit so that they can start performing their own analysis and spinning up their teams to get ready to perform this crazy 48-hour initialization period, and then on to nominal operations. And then I think it's around 7:30 p.m. on the 14th. We very successfully launched and met our requirement and delivered the space vehicle into orbit. And this here is just a picture of that. I think this may be my background on my computer for years. But yeah, so that's Victus Nox there, deploying off the second stage out into low Earth orbit. That's you can see Earth there in the background. All right. And then mission operations. Again, our task was to get this vehicle mission ready, right? It wasn't just good enough to build the vehicle faster than it's ever been done, to process it faster than it's ever been done, to launch it faster than it's ever been done. Most importantly, it needed to be ready to do its job on orbit as quickly as possible. And so we really went through a pretty vigorous initialization phase. Again, at a very high level, getting the solar arrays deployed and pointed towards the sun, checking out our avionics and electronics, and just making sure that our vehicle was operating nominally at a system level and in a safe state prior to proceeding towards our SDA type mission. And so, yeah, kind of deliberately didn't really talk about some of the timelines, some of the numbers, because just wanted to emphasize just the significance of what this team has accomplished, and just really how impressive it was. And so we had our vehicle. It was fully manufactured, fully environmentally tested within 8 months. We had our ground segment fully set up, meaning that we had received all of our security authorizations, and we had our mission operations center prepared in that same time frame. We had all the logistics planned out for the activation phase, launch, and mission operations periods in just 8 months. We completed the activation phase. Again, supposed to be 60 hours. We completed it in 58. That is despite a pretty serious electrical storm, a rare storm that came through Vandenberg, that actually required us to evacuate the payload processing facility because high likelihood of a lightning strike. We were launch ready within our 24-hour requirement, and we completed the initialization period in just 37 hours. And I think we've identified a handful of ways that we could even bring that down. So, I mean, really just a round of applause to these folks here for just doing an amazing job. Cool. And yeah, and again, one of the big reasons for this mission was to really stress test the system, right? See what breaks, capture those lessons learned. And, as I mentioned at the beginning, a big part of this was to really, push the envelope and identify those gaps. And, one of the biggest pieces that we did discover was, again, the people problem, right? Maintaining personnel and infrastructure to support these types of operations at a moment's notice. Again, 20 folks plus subcontractors, plus mission partners, plus launch vehicle provider ready anytime to deliver these types of vehicles. I would say, practice makes perfect, right? There's a reason why we were successfully meeting all these rigorous timelines. It's because, the team went through many, many iterations of, practicing all the procedures, including timing how long it takes through LA traffic to get up to Vandenberg Space Force Base. I think, we captured a lot of very, very important lessons that would apply to future tactically responsive space missions. I think with that, thank you all for listening. Big thanks to Space Safari and their leadership. Thanks to Aerospace Corporation, folks at Millennium Space Systems, folks at Firefly for everything everyone did to get this thing done. So thank you. Oh.
Andrew, I'm pleased to present you with this
wow.
certificate commemorating your your presentation.
Oh, thank you.
Thank you so much.
Yeah.
Got it? Okay. All right.
Thank you.
Thank you. Yeah. So congratulations again, and congratulations to Millennium Space for winning Foo Fighter as well. So yeah. So I'll say one more thing. We have Jim Wirtz with us this evening, and Jim will be taking the stage here in a few minutes. But we recall from, sorry to say, years ago now, too many years ago, the Responsive Space Conference that Jim and his team at Microcosm organized. It was administered in part by this section, the Los Angeles section, and the Space Systems Technical Committee that I was also on and chaired years ago. So, Jim, I think it's fair to say the dream of responsive space and reinventing space, which that conference became later, has been realized, or at least the first really important steps in that direction have been realized. So, thank you. Yes, it feels like it some days, but yes. So, all right, Ken.
We also want to add, we'll continue these two wonderful conference Dr. James was set up in the beginning. So Jeff,
We would like to reinvent the Reinventing Space Conference. So, so we should talk about that.
That's right.
And by the way, we could always use more jobs on the Central Coast. So if you want to avoid the LA traffic, you could. Yes, there you go. Anyway, let's go on and move into the next category. So we're going to recognize membership advancements, and I'm very pleased to begin that by recognizing someone who's achieved honorary fellow, a rare achievement in the Institute, and Professor Azad Madni from the University of Southern California. So congratulations. I'm happy to introduce you and geek. He's a professor of astronautics, aerospace, and mechanical engineering at USC, the Viterbi School of Engineering. That reminds me, I knew Viterbi when I lived in San Diego. Yes. Yes. Anyway, I was so happy when he donated that money for the School of Engineering. So your accomplishments are legendary and totally amazing. And so congratulations on this well-deserved honor of honorary fellow. All right. Would you like to say a few words or?
Well, sure. Well, thank you, Jeff. Yeah, this is an important event and kind of a crowning experience in my career in aerospace. And it turns out that I'm the first at USC in the history of USC to achieve this honor, and also the first Indian American to have achieved this honor. So I feel pretty proud of that.
Oh, congratulations.
On
Fight on. Absolutely.
Fight on, yeah. So in about 10 days or so, I'm going to be at the Washington Plaza Hotel for the dinner with Marilee and several others for the honorary fellow dinner. And then at the Kennedy Center, where we're going to have the big gala, where I'll have a chance to make a speech again on what this means to me. But my story is actually very simple, and I think you might enjoy it. I'll take just about 30 seconds. I was a kid growing up in India and still a teenager, and I heard John Kennedy's we go to the moon speech. And that kind of captured my imagination. And I told my father, I think this is something I really want to do. And he said, then go do it. So I came as an undergraduate to the United States at UCLA, graduated, and I had a dream come true moment when I was hired by Rockwell International to work on the NASA Space Shuttle program. I was able to make a significant contribution on that program, and I was recognized in 2021 with the IEEE Aerospace and Electronic System Judith A. Space Resnick Space Engineering Excellence Award. And then I went into startups after that and had been running a startup with my wife and co-founder of a company. When USC came inquiring if I would want to come and take over the aerospace program, systems engineering program at USC after Eb Recton had passed. And we've flirted for a few years, and then I finally decided to join because my daughter convinced me that I should. And today I am a professor of astronautics, aerospace, and mechanical engineering. And that little dream and the gleam in the eye of a teenager back in India is realized now, where I have now dozens of very successful graduates in the aerospace community. And, I would like to see that every young kid in this room today can aspire and dream big, because dreams do come true. And it came true for me. And I would hope that it comes true for all of you as well.
Thank you very much.
Yeah, just want to add that we actually print the article about Professor Mandi in the check-in table. You're welcome to pick it up. And again, this is a preview, so we are arranging a full lecture with Professor. So we're looking forward to that. So stay tuned.
And thanks for all your contributions.
Thank you. Thank you.
Yeah, you're most welcome. All right, well, let's move on now to recognize our class of 2024 Associate Fellows. And we have one with us this evening, my esteemed colleague, John Ehrenberg from Northrop Grumman. So John, please come forward. And congratulations, John. It's a pleasure.
Thank you.
Yes. I'd like to say a few words.
Just want to say thank you,
Oh.
and appreciate that. Fully conscious that nobody wins this by themselves, and so I appreciate my teachers, my mentors, my colleagues, past, present, future, and hopefully some of the students will come and join us and invent tomorrow, because we do it every day at work. Thank you very much.
Thank you, John. Very good. All right.
We go over the themes.
Yes.
So we go over.
Yes. Yes. So our next category of recognition is recognizing anniversaries, membership anniversaries. And the anniversaries date all the way from 70 years, continuous membership in the AIAA, to 25 years. And we have a few of those honorees with us this evening. The first one I want to recognize is my good friend, Dean Davis. And I'm going to come back there, Dean, and present you with this certificate. Way back there.
Jeff, we can come here.
Yeah, okay. I was going to take the shortcut, but it's all right. So Dean, congratulations. Thank you for your years of service, for everything you've done for the Institute, including taking calls from Buzz Aldrin at 2:00 in the morning with Buzz calling from Antarctica. That had to be a highlight of your time in the Institute. So. Yeah, right. All right. Would you like to do this?
Henry, you want to hear me? Okay, all right. It's now been 50 years since I started AIAA. I was at the University of Colorado and I was the section chairman for my student section. And what got me into aerospace in the first place was my dad took me to an air show when I was 10 years old, and I saw a B-58 Hustler flying at 100 feet off the ground, hitting Mach 1. Boom! And from that point on, I said, I got to do that. And so we all have those cathartic moments in life, and that's what triggered me to get into this industry. And it's been like Mr. Toad's Wild Ride. It's never been boring. I wouldn't change it for the world, but it would be nice to have a stable job someday. But I've worked on over 400 projects. If I had a stable job, it wouldn't have been the case. Worked air, land, sea space, from the deep space with the Voyager spacecrafts to the fastest airplane, the SR-71, to stealth vehicles, the B-2, B-21, F-22, etc., to oceanographic submersibles going to the bottom of the ocean floor, robots going inside of volcanoes, robots on Mars. And so it's been a wonderful life, and I wouldn't trade it for the world. Thank you.
All right. Well, thank you, Dean. Isn't it great being an engineer? Yeah, it really is. Yes. Yes. Why not do everything? He used to come to a lot of our sections. He used to come to this award banquet occasionally as well. So, well, the next person we'd like to recognize is Tom Mulder for 40 years of continuous AIAA membership. Thank you, Tom. Congratulations. And would you like, well, we're going to put our pictures first. Yes. All right. Yes. Yes. Let's take our usual. How would you like to say?
Sure, I'll say a couple. I'd be remiss if I didn't mention my wife right off the bat and everything she's put up with for 40 years, 42 years actually at Boeing. Yeah, AA has been really special in my life. I spent 1 year as chairman of the Houston section because we lived there for 33 years before moving up. And of course, I want to thank Boeing for putting up with me for all this time as well. Worked on the space shuttle program and really about 90 different programs, projects, and proposals that, I don't know, I'd call those contributions to Boeing. In particular, right now I work on this Spaceliner program. We launch on Monday. Yes. So I've got to fly to Houston to support that at Mission Control there. I designed the rendezvous trajectory and the autonomous guidance system that will get it to the space station within a little more than 24 hours. So fingers crossed this works because we have crew on this flight. But
Yeah.
anyway, thank you
Yeah.
very much.
Yeah, thank you. Yeah. We'd also like to recognize another member who's been with us for 40 years, Robin Harrison. All right. Congratulations and thank you, Robin. Yeah, would you like to say a few
I
words?
would like to say just a couple of words. I worked for the U.S. Forest Service as the program leader for aviation for 30 years. And we had a saying that all it takes to get 1,000-year-old forest is 1,000 years. Well, all it takes to get a 40-year-old AIAA is to pay dues for 40 years. But
You could just become a lifetime member.
although I haven't been as active in the AIAA as I wish I could have been, the influence of AIAA members, the magazine, the papers have been an incredibly important help to me in my career. I'm retired from the Forest Service. I'm a consultant structural DER. So if anybody out there needs any 8110-3s, 23, 25, 27, 29 airplanes, my wife has got business cards. Thank you.
Right. Thank you very much. Congratulations. Thank you again. All right. Well, we're now going to move into the Sustained Service Awards. And it's my pleasure to present the first one of those to Marilee Wheaton from Aerospace. Marilee is extremely well known across the Institute, and I was in a couple of meetings earlier today related to student conferences and that sort of thing. And when you say Marilee, everybody knows who you're talking about. It doesn't have to be qualified. Exactly. So congratulations and thank you for everything you've done for the Institute. Yeah. Yep.
I have to give a public service announcement though about these awards though, and this is really nice, but the one you get from AIAA is, amazing. And I think this award is really under utilized. It's different than some of the others because it's not as qualitative. It really is quite quantitative. So in other words, and it's easy to give to unsung heroes that have done stuff for either at the local, regional, or national level over a large number of years. And it's point-based. And there's a form. And so, they keep track of the person, what they've done for AIAA. And usually after about at least 10 years, you actually, if you've been continuously doing things, you can get up to, you have to at least 100 points to be eligible for it. But they give up to 20 each year. They can in the rules. And like this year we had 7. I happen to be the only woman of the 7, which was of interesting. So we probably need more women to be nominated for it. But I think it's underutilized. And so I just, want to recommend to anybody, if you know someone within the LV section that really has done a lot over the years, volunteered for a lot of things. There's a space on the form for all sorts of activities. You don't have to be on the board of directors. You don't even have to necessarily be on a lot of national committees. If you've been very active in the local and or regional, you definitely are qualified. So anyway, I did just, I'm on the Honors and Awards Committee for AIAA now, and I just feel like this award a lot of times is underutilized by the section. So
Yeah.
I have to mention that.
Yeah, thank you for mentioning that.
Yeah,
Yes.
but thank you.
Oh, congratulations
yes.
again. All right. Yeah. So I'd like to turn the mic back over to Marilee, who's going to make another presentation.
So, yes, Luis, okay.
Section branch. This is a section.
Okay, all right. Okay, let's do Ken's Sustained Service Award. So when I said people that have done a lot for a particular section over a large number of times, I tend to look for those individuals, and I actually served as the nominator for Ken for this award. You do have to coordinate with the person because a lot of times you're not as familiar with everything they've done, but I got to know Ken because he started this series for celebrating the 19th Amendment for women's suffrage in August, and we've been doing for like the last 5 years programs, and so I thought that was really kind of a added. And then I realized everything else he's done for the section, so definitely well qualified. So I had served as the nominator, so I was really thrilled when then the committee decided to award it to him. So
Thank you, great pleasure.
over to
honor.
you.
Thank
Yes,
you.
yes, yes.
Love to do more with
Yeah,
you.
yeah, yeah.
Thank you so much.
Okay.
Oh, yeah.
Yeah.
Yeah, we'd really love to work with Mary Lee. Have been trying to support her, and she's really good in professional career and also helping all the member, new generations. And she's very good in events. So hopefully we can continue to work with her for more exciting events. So again, she's our big family leader. So everybody look up here. Very inspiring for all the professionals, especially for women. So we love to continue to support the women initiative. Thank you.
The other thing is, as I mentioned, I'm on the Honors and Awards Committee. I've also been one of the chairs for the Fellows recognition. I served as the chair for PAG for the space and missiles area for a couple of years. So I did learn a lot by serving on that. So if anybody ever wants any advice or guidance or anything for either associate fellow or the fellows, which I served on, I'm also happy to help. And I'm also happy to serve as a reference for anyone as well too. So just so folks know that. So our next certificate of recognition is going to go to Luis Cuevas. It's a section award. It's the Section Student Branch Partnership Award. So I want to recognize this. For Luis. Here we go. So let us know what activities did you do related to the student partnership that were especially important in this time frame?
Right. So we hosted as a section a student mini conference for the student chapters that are in our professional section. That's UNLV, UCLA, USC, and California State Long Beach. Students are amazing. They every time we've done this event, their technical presentations really wow me. They're got technical rigor, they've got great mentors, and they're really the students that present, they're really on the ball. So it's a blast throwing this event every single year. Seriously, it's great to empower this community and really grow it and reach out to young students and show them that connection to the upper levels, if you will. So thank you.
Thanks again for your service.
Thank you for Mary Lee and Luis. By the way, this is for last year. This award is for 2022 and 23. So later you will see we actually have the one for this year. But the section award, national section award will be announced in August, September for the previous year. So Luis is for last year. Hopefully we win again this year with Ian. Okay. So Jim.
Yes, thank you.
Oh, so that's right. As I cannot mention enough, Dr. Fisher has been 3 times section chair. He pulled us back to the healthy stage. And not only that, he continued to play a very important leadership, continue to guide us through all kinds of possibilities. And so 2 or 3 years ago, Dr. Bushell initiated the section Best Event Awards. So this year, and we have been trying to get back to Escape, and Dr. Bushell really made it. It was very difficult after pandemic, but he succeeded. It was just amazing. It's like a miracle. And by the way, this March 5th event was the this U2, the spy plane, spy pilot event was very well received. A couple of people here, like Gary and a couple of people that were actually in that event. So it was very amazing, very well received. So here we thank Dr. Bushell for getting the best event he initiated 3 years ago. So this we make a special appreciation. As you notice, event activity is really the key thing for AIAA to keep members interested, engaged, and getting new members. So thank you, Dr. Bushell. 1 second. Forget. This is very important. Luis, thank you. Thank you. Take a picture. Thank you. Thank you, Dr. Bouchard. Thank you so much. Thank you. Thank you.
Let me just say thank you, Ken. First of all, you're the events chair. So this was an event that occurred under your leadership, and the amount of work you did to make this happen was just amazing. So I really thank you for making it happen.
Actually, then I have to return back. Actually, Dana and Jeff, a few years ago, I learned a lot from them. Not only for the detail, I learned from Dana, but also every time we've been the art in downtown, art event and many other events, I saw Jeff after the event carry our section banner. It's just like he's carrying the section AIAA on his shoulder. It's like a giant. So I learned a lot from Dana, and this great event with Dana as well. So really, yeah.
Well, thank you, Ken. And thank you for your enlightened leadership as chair over the past couple of years. I think you're moving on, and we'll have a new chair next year, it sounds like. So I can't thank you enough for your service as chair. And I know you'll still be intimately involved in many things. One thing I'll mention is we actually created a new award at the Region 6 level just to give it to Ken. So
Thank you.
yes.
Appreciate it.
Okay, well, you're welcome.
Oh, thank you so much. So now back to you. We do have a very amazing event at the section, continue the tradition from Dr. James Worth and Dr. Bushell. So we have another wonderful event that is kind of continuation was what Luis got, but we have a different type of event. So Jeff.
Yeah, so I'm very pleased to present the Best Event Award to Ian Clavio for the Student University Branches Mini Conference, which I think is a tremendous idea. I think it lays the foundation for future conferences, perhaps growing it into an even more complete conference. So Ian, congratulations. And thank you for everything you've done. Yeah. Would you like to say a few words?
Yeah, I can say a few words. So I'm absolutely honored to get this award on behalf of the AIAA LALV section. This is actually my first year being the education collegiate chair for the student branches. So it's been an honor working with these folks, and I know they've been doing a tremendous job throughout the academic year, and I'm going to continue my best is to giving them many opportunities for growth in their academic and professional careers. And there's more to come in the future. So I can't wait to continue working with them and also with the student branches as well.
All right. Thank you very much.
Yeah, bravo. I just a notable mention because actually Mr. Yan Helbin from Spin Launch supposed to be here. He really wanted to come here and meet Dr. Worth, Dr. Bushell, everybody. But unfortunately, they have a meeting, so looks like he cannot make it. So he kindly sponsored this event that with Ian and us, and we have a wonderful tour, as you can see in the picture. He's right here, and he's really interested in responsive space. That's what his company is trying to do. And I've been trying to help him to connect to our community. And at the same time, the company provide this kind of outreach tour opportunity. This is a kind of model we want to work with some of the companies, institute, and by the way, you got network. So we even have former council member, Mr. Jerry Lockenauer, coming back from Pennsylvania to attend this event in Long Beach. So we thank Dr. Yan Helbin to sponsor this event, and we'll support Ian for this great opportunity. Thank you.
All right. Thank you. Okay. Oh, Gary. Okay.
Gary and Luis. Okay.
Yes, these are now, excuse me, we're now recognizing notable events. And we're very pleased to have two of our council members here, Gary Moyer and Luis Cuevas, for two different notable events. In the case of Gary, it's the Aircraft Designers, a Northrop Grumman Historical Perspective. Gary, sounds like a fantastic event. Sorry that I missed it, but I heard all sorts of about it. So congratulations. And Luis, this sounds like a really good event that I really regret missing, the Young Professionals Happy Hour. I was on TV. That's true. Yeah, but you were having all the fun. I was watching you on TV. Yes, yes. So yes, I'm happy to hear that. So congratulations for being recognized, and you're invited to say a few words if you'd like.
Yes, well, this was an event that featured one of our members, Mike Chimenera, who was a aircraft designer. He was head of the advanced design departments in Grumman, and then subsequently in Northrop Grumman. And he has written 2 books. The first one is The Aircraft Designers, a Grumman Perspective. The second one is The Aircraft Designers, a Northrop Grumman Perspective. And the second book is about 800 pages. It was published with substantial support from Northrop Grumman Corporation. And we want to put it up we're putting it up for the book of the year right now.
Yeah. All right. Thank you very much, Gary. Luis, would you like to amplify the happy hour? Yeah.
You're all invited to the next one.
Yeah. All right. Thank you both. Right. Now we're moving into the student awards. And I just want to make sure we go in the right order.
Yeah, that's the college first. So
Yes.
Cal State.
Cal State. So we're,
It's not awards.
yeah, recognition in this case. Yes. And so one of the student chapters in our section is the beach, Cal State Long Beach. And they were selected for a student CubeSat project called SharkSat. And so we have some of the students here from that team. Would you please come forward?
Also the mentor, Dennis, mentor, you are the mentor. How come?
And you're all given the opportunity to give 5-minute speeches if you'd like. Actually, if you'd like to say a few words.
Yeah, I could give like a short speech.
Sure. Congratulations.
Thank you.
That's quite an achievement, actually. Yeah. Yes, yes, congratulations. Congratulations. Yeah. Yeah, that's right.
Yeah, sorry. I'll keep it pretty short. So just quick introduction. I'm the project lead for the team. My name is Jaime. I started the team in around March, really. And I'm really appreciative of Dennis and Kenneth. I actually met Dennis at the AIAA mini conference last year, and he was able to connect us with a lot of people in the industry and was really, really helpful in getting us started and connected with a lot of industry experts. Just like a quick introduction of like the CubeSat and the mission. So, we're making a 2U CubeSat that will monitor light pollution around the world. We're mainly focusing on the lower wavelength spectrum, so specifically blue light. That's important just because right now, I don't know if right now what's mostly being used in like lights is LEDs, and LEDs produce a lot of blue light. And there isn't any recent data on blue light pollution. And so that's kind of what we're focusing on.
That's a great idea. I mean, truly great idea.
Thank you. Thank you. Thank you, everyone. That's kind of all I have to say.
Well, thank you.
Yeah, just to add to that, I just want to say thank you to Kenneth and the AIAA LV section. Thank you to all of you guys for being here and giving us this opportunity to recognize my team's achievement. I guess I didn't say who I am, but I'm the president of the AIAA student chapter at Castle Long Beach. My name is Pedro. I would also like to thank my team Andrew Ramirez, he's here supporting the vice chair. And then everyone else at Castle Long Beach. Yeah, thank you all around.
It's a pleasure.
Sure.
My name is Dennis Leung. I met these guys not too long ago, but I would have to say very impressive. We've got them from zero to winning a proposal in less than 3 months. So I have to say these guys did a fantastic job and they deserve a lot of credit for what they've done. And we're going to do it the same thing for UCLA this year.
All right. Thank you very much. Okay. So this one may work a bit better. We'll continue on now with student conference papers. So I mentioned before that I'm the Region 6 Education Director, and we just had our student conference up at Santa Clara University about a month ago. And this section did quite well in terms of our student chapters placing well. So we have some of the award-winning paper authors here with us this evening. Christina Aziz from SC. Maybe not.
She didn't show up.
She didn't show up. Okay, you thought she would.
So she.
Okay. Anybody here from the team? No.
This is
Okay.
the only team.
Okay. Well, we'll give them even more special recognition then. Another award-winning paper authored by Cameron Cohen and Autumn Zaretsky is on characterization of an adamantine thruster by a Langmuir probe. I read every single one of these papers and they were all excellent. This one stood out to me. So congratulations on your award. Congratulations to both of you. So, and you're invited to say a few words after Ken takes.
We'll keep it pretty short, but we just want to thank Aspen, which is the club that we worked with to make this project possible, as well as our advisors, Dr. Breeden and Dr. Gilpin, and of course, USC Viterbi, and finally, AIAA for making the student conference possible.
Well, congratulations again. If you were talking.
I think Cameron basically covered it, but yeah, there was a lot of people at USC who helped us make this happen, including our professors and even the USC Astronautics Department for helping fund us to come to this event tonight. And I would just like to thank Cameron, my research partner, for putting up with me with all the late nights. Yeah, it's been a great experience. So thank you.
Oh, go ahead.
Yeah. There's actually a very important person behind the scenes is Dr. Mike Grantman, because immediately he heard that we are going to recognize this. So he immediately asked me who are the USC students. So whoever that he tried to get the support for their coming here. So he's the person behind the scene. But he,
Yes.
unfortunately, cannot make it. He's on the trip. He cannot make it today. Thank you.
So one thing I'll mention, especially for the student chapters, is we just received some funding from AIAA headquarters, a couple of $1,000 for student events. And so you'll be receiving an RFP, request for proposal, from me to propose a project and with funding to go with it. So it won't be a huge amount of funding, a few $100 maybe, but you'll be the first to know since you came to this banquet. So. Okay. High school. Okay. All right. So now we're moving into the high school category of awards. And the first award is the High School STEAM Award in the general category. The paper is Creating a Piano Critiquing Algorithm Using Artificial Intelligence. I could have used that when I was taking piano lessons. So. And the winner is Henry Wong or Wang, and I apologize for not knowing which way you pronounce it, but I'm very pleased to present this certificate to you. So, and check. Congratulations.
I'd like to thank the AIAA obviously for giving me this award. It's a huge honor. And while not here, I'd also like to give a shout out to my piano teacher for giving me this idea. And then over there in the back, also I'd like to thank my dad for like helping me and like teaching me about how to create all these algorithms and getting me into like computer science in general. So yeah, thank you.
For a moment, shamelessly plug the student conference again. We are the only region that has a high school category for the student conference. And we had a paper from Orange County this year, but LA did not show up. So next year it's going to be in Irvine. So I invite all the high schools in the LA section to participate. The next winner is Vincent Chang for his paper on a convolutional neural network-based pipeline for multi-class classification of brain tumor MRI images. Wow, very impressive. Please join us, Vincent. Congratulations.
So as you guys must have heard like a few seconds ago, I am Vincent Chang and I did this project thing. Yeah. So I would really love to thank AIAA for giving me this award. I am very honored to receive this. And I would also like to thank my my teacher, which is also my mentor at Peninsula High. His name was Mr. Greenberg, and for all of his help given to me, because this is actually my first year doing like science research and stuff and like just generally science-based projects and stuff. And he gave me a lot of help on based on like what I can do about my board, what I can do about my presentation. So it's been really nice. And I would also like to thank two more people on the very far end over there, my parents. They gave me a whole lot of help with my presentation and everything. Thank you.
All right, very good. Thank you. Congratulations. All right, well, our next winner. Our next winner is, yeah, you can hear me. And I apologize if I mispronounce his name, Sneha Ramanuja. And I, again, apologize if I got that wrong, for her paper on Got Space Junk, a path optimization algorithm for orbital debris removal. Would you please drop your resume off on the while you're up here? Yes. And congratulations.
Sure. Thank you for AIAA for this because it's a huge honor. And also, I'd like to thank my dad and my parents for listening to me whenever I had like multiple different ideas and helping me sort them out. And I'm really excited to keep doing this. This is my first year too. And so I'm just excited.
All right. Thank you.
I just want to add the words. Actually, Sneha just joined the free high school membership of AIAA. So encourage, it's free. So encourage all the high school students here to sign up online. It's free. It's good for you. Thank you.
Right. So our next award winner is Aiden Kwan in the aeronautics category for his paper on bio-inspired wing design, aerodynamic simulation, and autonomous flight tests for airborne wind energy. Fantastic. Oh, congratulations. Yeah.
Um, I'd like to thank my teacher, Mark Greenberg, who's my science research advisor and mentor. He's guided me throughout the year, helped me with my project, and got me through every hurdle that I faced. So I really appreciate his help. I'd like to also thank the AIAA for giving me this award. It's a huge honor, and I really enjoyed my time here tonight. So thank you.
Thank you very much. Congratulations. Ah, okay. Yes, yeah. Well, this is the essay. Okay, okay. Just want to make sure we cover everything. Well, at this time, I'm going to turn the microphone over to Jim Wirtz for the presentation of the Jim Wirtz Scholarship 2024. James Wirtz, excuse me, shouldn't be so informal when it comes to a scholarship. Yes.
Thank you. And Anish Anand is the winner for the scholarship this time around. And we appreciate it very much. Do we have any of his background? Are we going to hear from Anish? Come up. Ah. ICM, the International Science and Engineering Fair, 2 straight years for exceptional research. Ah, here it is. And we certainly appreciate it. Prominently involved in the Peninsula's Award winning Stellar Explorers and Science Olympiad programs. Currently taking advanced computer science and calculus alongside chemistry. That's quite a collection. In any case, congratulations. With your third hand, we'll shake hands. Thank you very much.
I would like to thank the AIAA for all of their support for coming to the PV Science Fair and supporting all of our students there. And I was a member last year, and I'm going to continue being a member this year because I've enjoyed this. I've enjoyed being part of this very much, and I'm really appreciative for this award. So thank you all.
We appreciate very much the work that you've done. Thank you very much. You want to hold this? Thank you.
Oh, yeah. All right, thank you. All right, I think the final award for this evening is another award that's very special to me, actually, because during my first time as chair of this section, in fact, I was chair of the SSTC when we really started this Space Systems Technical Committee, the nationwide middle school essay contest. And for the very first time, it was nationwide. We had one entry from Manhattan Beach, and it was really good, and she won the national award. So I'm hoping we had more than one this year, but I at the request of Dr. Ken Louie, I did read these papers, and I thought this one was quite good. The title is The Effects of Space Observation on Environmental Monitoring. And Riley Meager, I'm not sure how to pronounce the last name for sure. Is Riley here? Ah, yes, good. Good paper, Riley. Yeah, could you correct the pronunciation of your last name? Mahar. Ah, I'm so sorry, I was way off. So, but congratulations. Welcome to say a few words as well.
I want to say thank you to AIAA for this amazing opportunity. And I'm so grateful to grow up in a time period of such outstanding innovation and opportunities and resources that allow my generation to learn about, understand, and learn about how to protect our planet.
Thank you so much. Thank you. You are the future. Well, that wraps it up, Ken. You have like 12 more awards we need to present, or we do?
Yeah, one last person we want to recognize is Mr. James Ball. I invited him to come here. He's in Chicago, so he cannot come here. But with just a recognition, because he is a renowned aerospace artist, has been designed for Ad Astra, is designed by Newsweek, Time Magazine. He volunteered for this free for our newsletter. So to get more attention for membership and people enjoy, newsletter is another platform for member to participate in newsletter, or you can edit feedback, give us feedback to it. It's another platform, other than presentation, other things.
Well, so Ken also does the newsletter, and it is the most amazing newsletter for a section for anything. I mean, it's right up there with space news, if you ask me, in terms of the quality of the work and the detail. And Ken has been recognized multiple times with the Communication Award for his work on the section newsletter. So let's congratulate Ken yet again.
I was really inspired by Dr. Bouchard, Dr. James Worth, and everybody, Mary Lee, Professor Madley, Dana. And it's amazing. So we'll continue to inspire all the generations, especially, get used to tonight. So we learned that actually also a couple of years ago in the AIAA Space Conference, we actually have 3 members. They happen to be also aerospace artists. So we started to pay, and several of we have Mr. Douglas, I think he left. We have a film screening event, aerospace art. It turns out a lot of our members, they were inspired by aerospace art. And that's how they become rocket scientists, astrophysicists, but they didn't even know who were the artists were when they were young. So we recognize this importance of it. So really appreciate it. And actually, I got inspired by Dr. Michelle about getting this done. And this artist is really good. He does it for free for us. Really appreciate it.
All right. Well, thank you all for joining us this evening. Have a safe drive home, and we'll see you next year at this award banquet. Thank you. Yeah. Turned out well. Excellent. After a rough start. Yeah. We finished on. Yeah, I made it out. Yeah. Nice to meet you. It's really nice. Yeah. And I